tonight's video, the goal is for us to work through 4 molarity problems. And the first one, what is the molarity of a solution of 100 grams of calcium chloride dissolved in 5 liters of water? Now, molarity is a concentration. It tries to describe how much of a solute is dissolved in how much of a solution. Now, we're going to use the units moles and liters. Now, I want you to check out the problem. Now, do you have moles or liters in the problem? Well, it turns out we do have liters, so we can use 5 liters for our expression of volume. But what is the mass expressed in? The mass is expressed in grams. Now, grams is not the same as moles, so we cannot use grams right there. We first have to do a conversion. So anytime a molarity problem is expressed in grams, the first thing you need to do is convert it to moles. So the first thing I'm looking at here is taking my 100 grams of calcium chloride, and I'm going to convert it into moles. Now, 1 mole of calcium chloride has an atomic mass of, I have it already given for us over here, 111 grams in 1 mole. So 111 grams of calcium chloride. Now, when I do the math here, 100 divided by 111, or I can say 100 times 1 divided by 111, we calculate that we have 0.9009 moles of CaCl2. Now, we're going to just round that off to 0.9. So we're going to call it 0.9 for our sake. And that works for us, 0.9 moles of CaCl2. It kind of works easier for our calculators, and it also works well for significant figures too. Alright, dude, so right now I have myself the moles of calcium chloride. I'm going to substitute that up here now. So step 1 was converting from grams into moles. Step 2 is going to be using our molarity formula. Now, we shorten molarity to be capital M. Molarity equals moles, which is 0.9 moles of calcium chloride divided by the liters of solution, and we said earlier we have 5 liters of solution. And we divide 0.9 divided by 5, we end up finding that the molarity of the solution is 0.18, and we use the capital M for molar. Alright, dudes, that is our first example of how to calculate a molarity problem. In the second problem, we're looking at here, what is the molarity of a solution prepared by dissolving 15 grams of sodium hydroxide, which is NaOH, in 225 milliliters of water. Now, we saw before that molarity equals moles divided by liters. So when we look at the problem here and the givens once again show us starting off in grams of sodium hydroxide, not moles. And this time we're throwing a little bit of a curveball. Volume is not expressed in liters, it's expressed in milliliters. So the first thing we're going to do is convert grams into moles. Now, a good idea, because this problem is very similar to the last one, would be to press the pause button, try to work this out on your own, then come back and see what I have. Here we go. In converting from grams into moles, I'm going to use my given, 15.0 grams of NaOH. Now, NaOH is the sodium hydroxide. It comes in pellet form. You can crush them up if you wanted to make it a little more fine. But that's what we're looking at here. And as I have shown right below the picture, that in 1 mole of NaOH, and we're going to label them just to keep it consistent and nice and clean, I have 40 grams of NaOH. And when I crunch the numbers, it's going to be 15 times 1 mole divided by 40. So let's do 15 divided by 40. End up finding that I have 0.375 moles of NaOH. Alright, dudes, so that has gotten us actually the top part right here in our formula. So we're pretty close now to calculating the molarity. Molarity is moles divided by liters. The second thing we're going to do is take our 225 milliliters of water and convert that to liters. Now the simplest way we could do it would be to just go 1, 2, 3 to move our decimal point over 3 places to the left, which would give me 0.225 of H2O solvent. Now we're all set, dudes. Third step is going to be to plug in the numbers into the molarity formula. Now molarity equals moles divided by liters. When I plug the numbers in, I have 0.375 moles of NaOH divided by 0.225 liters of solvent, which is water in this case. And when I crunch the numbers, I find that the molarity of the solution is 1.67 molar solution, which means moles per liters of NaOH. And I hope that's what you got too if you tried it on your own. Alright, dudes, next problem. Okay, and this problem is asking us how many moles of NaCl is needed. This is a little different problem. We're still using the same molarity formula. And just want to recall, dudes, we are looking for concentration. Molarity is another way of saying concentration. So how many moles of NaCl is needed? I'm stopping right there, and the whole problem is coming down to this. I'm looking at moles, and I'm trying to solve for moles of solute. Is needed to make a 6 molar solution. So I've given you now the molarity. The molarity is 6 molar in a 50 milliliter of water. So I have 50 ml. Alright, dudes, so in this case, the driving thing we want to find out is how many moles do I need? Alright, how many moles of salt will I need in order to make a solution? This is not too unfamiliar for a chemist or a scientist. You have a concentration that you have. You also have a given volume that you need to use, and you work backwards and find the moles. So and what we're doing is actually kind of common. So when we plug the numbers in right now, we have 6 molar equal moles of NaCl divided by 50 milliliters of solution. Now we know we can't use 50 milliliters. It has to be liters. So we're going to do the 1, 2, 3. Decimal point is over there, so I actually have 0.050 liters of solution. Now what I want you to do is isolate the moles. We're going to solve for moles. In order to do that, we need something that says moles equals. And so what we're going to do is multiply this side by 0.050 liters over 1. And that's going to cause these two to cancel out. Now when you do that, essentially we have isolated the unit moles. But I need to multiply that by the other side as well. So I'm going to do this over here, 0.050 liters over 1. And so the problem ends up working out like this. 0.050 liters multiplied by 6 molar is going to tell me how many moles of NaCl I have. And just disregard that squiggly line that went up there. It wasn't meant to cross out the 6. So let's crunch the numbers. 0.05 times 6 equals 0.3 moles of NaCl. Awesome here. So once again, the main question here was how many moles, and we have achieved that. And the last question here, the question is stating how many grams. So right off the bat, I like to stop and just identify what we're doing here. How many grams? So we're looking for grams, we're not looking for moles, and we're not looking for liters, and we're not looking for molarity. But if you recall from a few slides ago, moles and grams are linked together. So let's continue right here. How many grams of NaCl is needed to make a 3 molar solution in 150 milliliters of water? Alright, dudes, so what we're looking at here, we have a 3 molar solution that is going to be 0.150 liters. So I'll just scratch that out and go 0.150 liters. And it's the same problem essentially as the very last one, where we're first going to have to solve for moles. And once we have moles calculated, we're going to need to convert to grams from moles. So this problem has an additional step that the last problem did not have. Kind of important for us is we're going to need to know the molar mass or the atomic mass of NaCl, which is 58.5 grams in 1 mole. So we're going to need to use that later on. So let's rearrange the problem same as we did last time. What you saw from last time was that the molarity multiplied by the liters is going to equal the moles. And so we're just going to plug the numbers in now. The molarity was 3 molar. The volume in liters was 0.150. And when I crunch the numbers, I end up with 0.45 moles. Sorry about those straight lines. Somehow it's doing that. Of NaCl. Now that's awesome. We're almost there, dudes. The question is asking us specifically for grams, not moles. So we're going to take the last step, and now our new given is going to be 0.45 moles, and I'm going to convert that into grams. Now we saw a second ago that there's 58.5 grams in 1 mole. And so we're going to have 58.5 grams go on top, and we're going to have 1 mole of NaCl on the bottom. And so we're crunching the numbers here. 0.45 times 58.5 is going to equal 26.3 grams of NaCl. So the question, going back to originally, it said how many grams of NaCl is needed. And so if we're looking to make a 3 molar solution using 0.150 liters of water, how many grams would I need? Well, we first found out that I needed 0.45 moles, but when we convert moles into grams, we find out that it actually means 26.3 grams of NaCl. Alright, dudes, that was 4 molarity problems for you there. Hope it was awesome. Best wishes in your studies. Peace.